Hi, this is problem 10 from the AMC 12A. Integers x and y with x greater than y, both of which greater than 0, satisfy x plus xy equals 80. What is the value of x? Now, this is one of the most common forms of integer equations on the AMC, and it's a form that you need to recognize even if it's disguised in a word problem. And as with most integer equations, we have more variables than we have equations. We have two variables, x and y, one equation. And if we were to try to solve for x and y in a set of real numbers, we couldn't solve for x or y. But when we solve for x and y in the set of integers, we can usually reduce the number of possible solutions to maybe 3 or 2, or in some cases even 1. And the solution method for this is pretty straightforward. We take the equation xy plus x plus y equals to 80. Take the coefficients of the x and the y, multiply them together, add them to both sides. We can now factor the left side into a very useful form. And on the right side, we want to write 81 as all possible factor pair combinations. In this case, 1 times 81, 3 times 27, 27 times 3, and lastly, 81 times 1. Now at this point, we want to try to match up the factor pair on the left to the factors on the right. And what we notice is that from the problem statement, x is greater than y, so the left factor is always greater than the right factor, and that doesn't match up with these choices. And we also notice that both x and y are greater than 0, so each of these factors has to be 2 or larger, and that doesn't really match up with the last factor pair. So we've reduced our possibilities to one factor pair, 27 times 3, and since x is always greater than y, we notice that they have to match up with x plus 1 corresponding to 27 and y plus 1 corresponding to 3, from which we find that x plus 1 is equal to 27 and x is equal to 26 for choice E. And if you want to learn a little bit more about this particular integer equation form and a few other types of integer equation forms that are common to the AMC, check out the YouTube playlist Diophantine Equations for the AMC. And you can check that out if you're curious. Anyway, take care. Bye.